People are special. And so are triangles. Most right triangle lengths can be found using the Pythagorean theorem, but there are circumstances where the angle of a right triangle can help you find the side lengths. These are called special right triangles. There are two types, a 30, 60, 90 degree triangle and a 45, 45, 90 degree triangle. The side lengths have specific formulas. This is what makes them special. The formulas are pretty simple as long as you know the sides. In this diagram, the A's represent the two legs. They're both congruent because the opposite angle of them are both the same. In a 45, 45, 90 degree triangle, you multiply a leg, either one is fine because they're congruent, by the square root of 2 to get the hypotenuse, which is the side opposite of the 90 degree angle. On the flip side, to figure out either of the legs, you must divide the hypotenuse by the square root of 2. Basically doing the inverse of what you just did to figure out what the two legs are. Moving on, in a 30, 60, 90 triangle, you multiply the short leg by the square root of 3 to get the longer leg, and by 2 to get the hypotenuse. Let's practice. Example 1. The short side of a 30, 60, 90 triangle is 5. Figure out all the side lengths. To do this, you must multiply that side by 2 to get the hypotenuse. This makes it 10. Then multiply the short side by the square root of 3 to get the long side. Let's do another. Example 2. In a 45, 45, 90 triangle, the short sides are 6. Figure out the hypotenuse. To figure out the hypotenuse, you must multiply one of the legs by the square root of 2. That will give you 6 square root 2. Example 3. On a 90, 30, 60 triangle, the hypotenuse is 6. Figure out the other sides. To figure out the other sides, you must divide the hypotenuse by 2. This will give you 3, which is the short side. Then all you have to do is multiply the short side by the square root of 3, giving you 3 square root 3. That's all for us. Bye.